Welcome to our new chapter, Glide Planes, Screw Axes and Space Groups, and welcome to the first unit of this chapter. In unit 3.7 we already introduced glide planes and we saw how glide planes, or to be precise glide lines, act on objects in two dimensions, namely when we discussed plane or wallpaper groups. Now we want to extend the consideration of this kind of symmetry elements into the third dimension and want to discuss glide planes in crystal structures. As a short reminder, first of all we have to differentiate between the symmetry operation and the respective symmetry element. The symmetry operation is called a glide reflection, while the element on which we carry out this operation is the glide plane. A glide reflection is a combined symmetry operation, in which two operations have to be carried out consecutively. This means one after the other. First a reflection and then a translation by usually one half of the unit cell. One thing that is special about glide planes in crystals is that also glide planes exist where the translation component amounts to only 1/4 of the unit cell. There are 6 distinct glide planes that can occur in crystal structures. They are named A, B, and C, and N, D, and E. We will begin with the more simple ones, the glide planes A, B, and C. The characters which are used to name the glide planes express in all these 3 cases the translation direction of the translation component. So a glide plane A means that the translation direction is along the A direction or x-axis, and so on. Let's start with this glide plane A. We see here in gray a drawing layer, a projection plane of a unit cell. The projection plane is here the AB plane, and usually a glide plane is graphically marked with a dashed line. But because the glide plane lies in the same plane as the projection plane, an additional symbol is used. Such an angulate arrow. This is the plane, and this arrowhead indicates the translation direction of this glide plane. Now we place an object into the unit cell. And we have chosen not a simple circle, but an object which makes it easier to recognize the reflection operation, this locomotive. You know that motive already from some of the past units. Of course, we will again apply all of this to real crystal systems later on. This locomotive should be located along the C direction above the projection plane. Therefore, we indicate this with +Z. And now let's apply this glide plane A. First, the reflection. This means the locomotive is now behind the projection plane at a height -Z. And now we have to translate it along the A direction about 1/2 of the unit cell. The x-coordinate of the locomotive will increase by 0.5. As a two-dimensional drawing is always limited in terms of clearness, Michael was so kind to create a 3D animation of it. Let's look at this small animation. Starting with this locomotive, it is first reflected at this plane, then translated along the A direction, mirrored again, translation again, and so forth. Once again, mirroring, translation, mirroring, and translation. Let's look at the next possible glide plane B. Glide plane B means that the translation component is along the B axis or Y axis. Same scenario, but now the glide plane is oriented perpendicular to the drawing layer, marked here graphically with such a dashed line. Again, the locomotive should be located above the drawing plane. Now we first have to reflect the motive at this glide plane, and then translation along the B or Y direction by 1/2 of the unit cell. Again, let's have a look how this looks in 3D. Mirroring at this plane, which is perpendicular to the AB plane, then translation along B by 1/2, mirroring again, translation, and so on. One, in quotation marks, simple glide plane is left, the glide plane C. Here, the translation component is 1/2 in the C direction. Again, the same scenario, the glide plane runs again perpendicular to this chosen drawing layer, and a locomotive is placed here at the height z, but here z should be an arbitrary value behind the drawing layer. Okay, first a reflection is carried out at this plane, and then we have to move the locomotive along the positive C direction, and this means it will land above the projection plane at a height z plus 1/2. And also for this glide plane C, Michael produced a small animation. Let's have a look. First, mirroring at the BC plane, then translation by 1/2 in the positive C direction, mirroring again, translation, and so on. Okay, that were the 3 simple glide planes and crystals. In the next unit, we will have a look at the slightly more complicated glide planes left, namely N, D, and E.